All right, now continuing our discussion of the Mandelbulb 3D application network rendering, we talked about the overwrite existing images. Make sure that that is checked off so that you don't inadvertently have one PC Mandelbulb 3D animation overwrite an existing subframe. Obviously that would throw off your frames when you brought it into the video editor. Okay, so all right, so you want to make sure that your output folder is the network shared folder. Okay? You don't want to see something like C:/ Pat's PC. That is a specific address to a local hard drive. What you want is something that would indicate that you're pointing to a network share. Usually a dead giveaway is the 2 slashes, okay? You also want to make sure that you have a slash on the back side of that network location as well. Because what we want to do, if we take a look at our file manager, what we want to do is we want to write all of our subframes as they're rendered into a shared image segments folder. All right, so let's get that going. Okay, so checking around, PNG, okay, network folder for the output, start index of 1, so on and so forth. You know, oh, look at that. All right, let's get 1080. The reason that I get a little fussy with this whole thing, let's make sure we save it so that we have our other PCs will benefit from this modification. The reason I get fussy with this is because you really don't want to launch this thing on a mission of creating, in this case, 4,225 subframes, only to find out you had the wrong settings somewhere here and you got to redo the whole thing again. In my opinion, having my PC or PCs work on a Mandelbulb 3D animation for a day or 2 or 5 days, and the longest so far that I've run is 8 days with 3 PCs running. You don't want to put all that time in, not that you're sitting here doing it yourself, but you lost that time to be able to move your project forward, okay? There's nothing you can do with your project until the rendering of the subframes is done. You want to make sure that you have it set up right in the beginning, because once you launch it, you can have a PC working on it, or 2 PCs or 3, and you just go away and you live your life as normal. All right, so let's go ahead and punch this. I'm going to start rendering. And I think what I'm going to do is, rather than sitting here looking at one another, I'm going to cut the film, and we'll come back when the first one has rendered out. Okay? So I'll see you in a few minutes. Okay, so we're back. So while we were away, I went to another PC and began the animation rendering on that PC. Also pointing toward this shared folder as the output for the rendered images. So we see here they're coming in. A matter of fact, another one just popped in there. Now I have this PC, I stopped the rendering because what happens is the rendering is so intense that it's actually causing my open broadcast software, OBS, screen capture to be jittery. So I really, in order to not have my head jerk around, I actually need to stop this, the rendering of these high resolution. Uh, and I am doing high resolution, 1920 with an anti-aliasing of 2. All right. So, but this is demonstrating that I am actually performing network rendering with a low-cost file folder sharing approach. All right. And if we take a look at this, let's open this up. Yeah, okay, right, all right. The file is locked because my other PC basically laid that file down, 0 KB. Good, I'm glad that happened because it gives me an opportunity to show you what I'm talking about here. The other PC had basically claimed that file number and name, all right, and it laid it down as a claim. So when the other PCs come along and they are ready to process, they'll say, oh, 5 is claimed, 4 is done, 3 is done, 5 is claimed, I'm going to work on 6. So that's how the network rendering works. It's very, very simple. And what I did is I actually tried to open up 5, but there was nothing to show. Now, my other PC just finished 5 and has gone on to 6. Now I should be able to open up 5. And that is the render at 1920 by 1080 of my other PC. All right, so I think we've accomplished quite a bit here in terms of network rendering. I have a third computer, and I can get that computer going on this network rendering too, because I have the file, I've worked it out, and I've made sure that this M3A, this animation file, is good for network rendering. All right, so I can open that file from any PC I want, as long as the PC can reach this shared folder, which happens to be on the PC that we're working on now. Excuse me. So what I've done is I set up a shared folder. I set up a shared folder. I have made sure that the folder, I gave it a name, and I made sure that the folder has an everyone access, full control, because there's reading and writing. All right, so the permissions are good. All right, then what I did is I went to on a PC. I made sure that my animation configuration is correct. I checked the animation size, the resolution, the anti-aliasing. I checked the PNG output. I made sure that the overwrite images was checked off, and then I made sure that I had the proper network share address in there. Saved it, and once that's good, it's good for all the PCs. All right, so let's see how we're doing here. So, all right, so it looks to me, if I just kind of open this this date time a bit here, it looks to me that that other PC is taking about, let's see, looks like about 2 minutes. All right, 351 to 353, 2 minutes. Here's another one, 349 to 51, so that'd be about 2 minutes. All right, so basically we have a PC that's taking about 2 minutes to render each of these frames. So what do we got here? Let's check this out here. All right, so let me get my stylus going here. And I'll reach over here and get my calculator. All right, so let's get on a, let's see, let's go back. That's good. All right, so we know we have 4,225 frames. All right. Now, if we run that at 60 frames per second, then if I go 4,225 times 60, 4,225 divided by 60, that's going to give me a 70-second animation, and I'll divide that by 60, which is going to give me 1 minute and 1.17 minutes. So this is a 1-minute animation. But we don't need to make a 10-minute animation in our tutorial series. We did enough animation, and I believe that I covered enough of the topics to give you a very good idea how to go about building a really good animation. Okay. So that's kind of the math here. Now, if I was to run this at 30 frames per second, which I do recall in another session, I said, don't do that. Don't do that. I go 4,225, and I'll divide that by 30. And that's going to give me 140 second. And I'll divide that by 60. That's going to give me a 2.34 minute animation. But like I was saying before, please don't do 30 frames per second. It's not worth it in the end. Now, the other little simple math that I want to do is we got 200, we got that many frames that we're gonna render out. We know that these frames are taken 2 minutes per, because we could see it here in our file list. So that's 120 seconds per frame. All right, so 4,225 times 120 seconds is going to give me 507,000 seconds. I'm going to divide that by 60, and that would be 8450 minutes. I'm going to divide that by 60 again, and that gives us 140 hours. And I'm going to divide that by 24 now, and that's 5.8 days that one computer would take to render 4,225 subframes. Now, here's the cool thing about it. If I put 3 PCs, I'm going to let's see, if I do 3 PCs, let's just take this number down here. 5.8 days divided by 3. All right, 3 PCs will render this whole thing out in 1.93 days. I just took 5.8 and divided it by 3. If I take 5.8 and divide that by 2 PCs, it will take 2.9 days to render my 4,225 frames. Okay? Very, very basic math. Now, obviously, we want to, early on, we were talking about having a balance between the quality and the render time. And I think you can get a very good appreciation for why we make that effort to get a balance between quality and render time. because you can see here that it's going to take days in order to render all of this. The more PCs I throw at it, the shorter time it will take, thanks to the support of the Mandelbulb 3D software having network rendering capabilities. That's a huge, all right? But the key point here is that there's a reason why we were focused on obtaining a balance between quality and rendering. All right? All right. All right, we'll pick this up in the next session. I'll see you there.